And hello, and welcome to episode 4 of the Learning BC Development from Scratch series, where I, Steve Endo, try to learn BCAL development from scratch. It's a very authentic role for me because it is all completely new, and my goal is to walk through this process very much as a beginner and stumble and run into the problems that a beginner would run into, not knowing anything, and try to figure those things out and share what I learn with you. So, this episode will cover Chapter 4 of the AL for Beginners Workbook, which I'll mention. And because this chapter was kind of large, there's quite a bit of content it covers, I split it up into 2 episodes. So this is going to be a part 1 of chapter 4, where it's more of a discussion or the classroom session on the content being presented. And I will do a second video, part 2, where we finally get to the hands-on creating the scripts or the AL code for tables and fields and pages. So I didn't want to try to do it in one. It would be really, really long. So I thought it'd be easier to break it up. And it gives me an opportunity to add some additional content and not have to hurry through it. So with that, I'm going to try to flip between PowerPoint and a browser, and we'll see how well that goes. It's a little trickier than you might think, but let's see. So as I do this, I just saw an article, major internet outage, dozens of sites down. So we'll see how long this lasts. But with that, let me hop back to the PowerPoint. And okay, so as you may know from the prior videos, this series is based on the AL for Beginners Workbook by Christoph at MyNavBlog on Twitter. And this is a free workbook available on GitHub for download. You can just download the PDF. And it is a 100-page PDF that walks you through the process of installing Docker on your machine, Visual Studio Code extensions, writing your first extension, and now we're moving into creating tables and pages in order to develop a full-blown sample extension. So it's a great workbook for this journey, so I'm using it as a basis for all of these videos. So big thanks to Christoph for providing this to us for free. Okay. So chapter 4, part 1. Chapter 4 is about table objects and page objects and fields in there as well, table fields. But I have, as I mentioned, I'm breaking this up into part 1 because he shares a lot of information about tables and pages, and I don't want to gloss over that or just rush through it. I want to kind of dive into it and discuss it and share my thoughts. And so this time it'll be the information about tables, about pages, and then next time I'll get in the code. And again, as with any blog post or video these days, this is as of August 2020, the best that I can do with the information I have available. If you're watching this later, 6 months, 12 months later, things may have changed. Hopefully not too drastically different, but things may have changed to the point where you need to re-verify some of the information. And if you find that some things are, completely changed or problematic and you can't follow along, let me know, post a video or post a comment under this video. Let me know, I'll get that comment, and maybe I'll put a note or maybe I'll redo the video, not sure. Okay, so moving on. So for the objectives, get familiar with the objects types of table and page. So those 2 object types. Understand init, insert, get, and reset. Get familiar with if else. Develop the setup for the extension, so the setup record, and develop the bonus card, which is, I believe that was in chapter 2 or 3 where he explains what this bonus card extension project is. So, okay, so he shares that tables have these elements or these things we want to know about. Tables have properties, fields, and he separately mentions flow fields because they're kind of their own unique entity, field triggers, table keys, and table triggers. And if you've done any type of client-server development, database development, application development, this is all probably pretty familiar with flow fields and perhaps field triggers being slightly unique. But other than that, tables, properties, fields, triggers, it's pretty standard application stuff. But obviously, Business Central and AL may implement them slightly differently. But we get the concept if you've done development before. Okay, so table properties. Here's a link to the Microsoft Docs page on table properties. Now, it is a combined page. It includes both table and field and some other properties. So there are like 55 items on the page. Only 22 of those are, as far as I could tell, actual table object properties. So you kind of have to sort through or search for table object to figure out which ones are relevant to tables. He offers 4 as being relevant for what we care about for this project. One is data classification, which is a pretty cool property. It allows you to set a property value for your table to indicate the nature of the data to be stored in that table. And that's kind of nice, saying, okay, this is just system metadata. It's not sensitive, it's not a big deal. Or this is sensitive customer data. We need to be concerned about this for compliance reason, data breach reason, whatever regulations or data compliance requirements you might have. And I was informed that this field came about with the advent of GDPR, data privacy regulations. So, however, there are many other countries, and in the US, additional states are adopting their own data privacy requirements. So I have a feeling this is going to become a very widely used, important field in Business Central. So it basically helps you to manage security, compliance, and privacy requirements. So it's going to be something you're going to want to be aware of. Caption sets the text string that displays in the user interface. Kind of cool. So you can set this caption at the table level, and it provides a user-friendly description for the table, presumably. Drill down page ID and look up page ID. I can guess what those are for, but the description is a little confusing, so I'm curious to see how those work to better understand exactly which does what and how you use them. So the ID of the page to use as a drill down, I'm not quite sure what that means. I'm sure it's obvious, but as a new user, it's like as a drill down to the table, from the table, like what does that mean? Or if you're on this table, do you drill down into somewhere else, like a child record? And then look up page ID, the ID of the page to use as a lookup. What does that mean relative to a table? So I'm sure we'll figure that out. Oh, and for the URL, let me just hop over to that page. So this is what that page looks like. And I'm doing this because I spent hours navigating through the BCAL docs pages trying to make sure I understood how it worked. And some of these pages combine different things that you might not consider related. And my understanding is that this organization is the way it is because many of these pages or much of this content is automatically generated, presumably based on source code or the AL source, something like that. So the docs team isn't manually maintaining these pages. So, and I fully support that because that's impossible. So when these are auto-generated, they only have certain flexibility or certain limited ability to organize the pages or break them out. So you will notice many cases a few topics that a person wouldn't normally group together. They are grouped together on one page or under one category, and you may be confused when you're searching for things. So for example, table and table extension properties. Well, yes, access is a property of a table, And if we scroll down here, yes, data type is a property of, or excuse me, data classification is a property of the table object. However, if you look up here, access by permission, that is a field level property. So what this page is combining is table object properties and field properties all in one page. So if you are aware of that, it will make your navigation of these pages so much easier and so much less confusing. I was quite confused trying to find where the documentation was for certain objects until I realized this, and now it's like, much simpler. I like the pages better now that I understand that, and I just know I just need to do a little filtering as I read them or as I scroll down. So with that important note, so that's table and table extension properties, but I'm going to refer to it for now on this slide as table properties. And out of the, I believe, 55 or so properties on this page, 22 of them relate exclusively to table objects. Some are shared, some are both table and field properties. So you'll just need to take a look and see. Okay, so I mentioned data classification, caption, drill down, and lookup properties. And so those are the ones that Christoph mentions in chapter 4. Okay, so next he lists popular table fields. And this is very familiar if you've done any type of database development. Most of these should be familiar. Text, date, integer, decimal, Boolean, things like that. Pretty standard stuff. You'll want to verify the data types because in my experience, every platform, every database architecture, and every application layer, development language, you name it, they have their own slightly different definitions for what is char, text, varchar, int, big int, things like that. But you get the point. Now, there are a few different field types for AL. So for instance, code. That's not something I'm very familiar with in the .NET or Dynamics GP world. So code is an alphanumeric field that is automatically converted to uppercase. It is used storing unique values such as a primary key, and you might use it for customer number or code in a dictionary. So that's very helpful. Customer number, that resonates. So I'm going to create a new customer record, and the customer ID will be stored in the database as a code. So rather than use a text or a char or varchar, some type of string variable, a code is kind of nice because it automatically gets converted to uppercase. You typically have a convention that it is the primary key, and it has, in most cases, 10 or 20 characters. So it's typically short and perfect. I'm fine with that convention. Sure, you might use a char, a varchar, an nvarchar, but code is kind of a convenient convention for storing those fields, and it has some additional connotation to it. And additional properties here, setting not blank will force you to put an not empty value in the field. So you'll have to specify customer ID, for example. Adding table relation will allow you to look up the values from a different table. Interesting. So if I think of this as let's say a sales contract for a customer, maybe the code might be a customer ID, and that would allow me to have a table relation to the customer table and do a lookup that way. Just a wild guess. So these are some common fields that he lists, Christoph lists in chapter 4 of the workbook. Now, when I saw that, I thought, okay, those are common ones, but I'd like to know where the complete listing is of all fields. So I found the Microsoft Docs pages for the table field types and field properties. And so this first one is called field type option type. Again, kind of strange naming. I'm going to write it off as due to the automated documentation, but field type option type, kind of strange. So let's take a look at that for a minute. And let me go over to tab number 2. So here we are, field type option type represents the type of a table field, okay? And I think there are different types of fields, so you probably do not, at least so far from what I've seen, I'm going to avoid referring to the word field generically because I think you could have say a field on a page, so a page field. So I've tried in my slides and references to specifically refer to table field to avoid confusion with other types of fields. So here we have the types of table fields, and we have, let's see, how many? 18 different types. So usual suspects, Boolean, integer, big integer. So let's go back to integer. So negative 2 billion to positive 2 billion corresponds to the SQL data type integer. Excellent, that's good to know. And that's kind of nice that this integer goes up to 2 billion. I forget what the .NET is, but there's int 16 and int 32 that's gotten me into trouble a few times because I think the int 16 is only 32,000 if I'm not mistaken. And I've mistakenly typed that with IntelliSense. It's right there, and I've chosen int 16 rather than int or int 32. So this is kind of nice. I'm totally cool with integer. We have the database storage. It really doesn't matter. Just go for the 2 billion, and that's a negative and positive 2 billion, so that's good. Big integer, 64-bit integer. So that's a really big number. I don't think I personally come across a need for that. But then we have decimal, and that is negative 10 to the 63 or positive 10 to the 63. Now, just reading this. Okay, so I came across this discussion recently in a quote somewhere that I believe decimal data types are technically approximations. So the representation of a number is binary and the size is decimal 3820, and it is held in memory with 18 significant digits. So technically, if you perform a lot of math calculations on a decimal value and you need very high precision, the limited significant digits and the limited precision can result in some rounding errors or some imprecise values, if that's the correct way to put it. So be careful with that. And so we recommend that you construct decimals to operate on numbers in the range of whatever this big number is, millions, billions, trillions, 999 trillion. You can construct larger numbers and cases, but overflow and truncation or loss of precision can occur. So you want to be careful if you're dealing with crazy large numbers, and unless you're into light years and cosmology, hopefully you're not dealing with financial numbers that are this large, or inventory for that matter. So just be aware of that danger. I don't think I've run into that issue with decimals or currency, but it is possible. Option. An option is defined by using an option string, comma separated list of strings. Okay, each valid value of the field. Okay, so I'm just going to guess this is kind of like a drop down or select from a list type of thing. Then you have text and code. We talked about code, date, time, and now there was a, I think it's later on, there is a field property that does exist that the docs specifically mentioned they do not recommend using. And I think it was a date property. So just be aware, some of these may be holdovers from older architectural versions, and you may not want to utilize all of them just because they exist. So check the docs and see. But you see here, you've got your usual suspects. GUID, that's kind of nice. Record ID, table filter, security filters, blob, media, and media set. So that's the docs page for field types. And next up, we have field properties. And this is different than the field data type or the data type for that field. And The reason I mention this explicitly is because there is no listing in the docs TOC for a field object. It's just not broken out for whatever reason, presumably due to the automated documentation process. It doesn't elevate to the level of getting its own TOC listing. So when you create a field in AL, in Visual Studio Code, you'll type field, and I was wondering, well, what do I type here? What options do I have? What properties can I set for this other than, date, time, or code? And there was no documentation. Well, it turns out, as I mentioned before, it is combined with the table properties listing in the automated documentation. So let's take a look at that. Let's go back to table and table extension properties. This also includes your field properties. So for example, access. You can have a field level property for an individual field, say access, or you can say access by permission. Let's find one that kind of is easy. So auto increment. So let's say you have a big integer and you want to auto increment it with each record. So I'm just going to drill into that. So sets whether the field value should be automatically incremented. Now you'll notice in this doc page, it doesn't break out where this is in the TOC. So if you happen to search for this and find it, you can get to this page, but you'll have no way to navigate back to its parent. You don't have breadcrumbs up here. You don't have anything showing you where in the TOC it is. So just want to mention this because I'm finding that I'm regularly going into the docs page and that they're very valuable for lookups as a definitive source for information. So just be aware when you want field properties, not just the data types, you'll want to go to this table and table extension properties page. And so what's another one? Caption, right? And what does this X mean? Available for table available for table extension objects. So a table extension object is another animal that I'm not going to dig into with this video, but we see that captions. So a table can have a caption and a text field can have a caption, for instance. So this caption property at the field level is combined with the table and table extension properties page, even though it's not explained at all in this title. So knowing this will clear up a lot of things. Whenever you're defining a field in AL, check out this page to see what properties you might want to set. Okay, let me just check audio here. Okay, we are doing good on the stream. Okay, so next up we have, okay, so that was field types and field properties. Very good to know both of those links. SQL data types. So Henrik offered this very cool suggestion to be aware of the underlying data type. So we saw a reference in docs that the integer data type was tied to the SQL Server underlying physical or SQL Server table and field data type. So that was great to know. But Henrik offers this link to the old nav documentation for the underlying SQL Server data type. So let's take a look at that. Close this. So here we have SQL Server data types in Dynamics NAV. So for instance, if I choose date formula, what is that stored as in the database, the physical field? varchar 32. Okay, so I'm not sure what situations you would need to know this. My understanding is typically you'll want to operate through the Business Central AL application layer and get all of your data that way. But if for some reason you want to know what the underlying SQL Server field data type is, this is your page for that. So that's good to know. So let's take a look. Integer, there's our SQL Server integer value. And that is the 32-bit, and then big integer is big int. So good to know in case you're interested. FlowFields. So flow fields are a very interesting feature of Business Central, formerly part of Nav. And they display the results of a calculation described in a calc formula property for the field. For example, the account balance field in the general ledger account table shows the balance of the account and is calculated the sum of the net amount fields for all general journal entries in the account. So to put this in beginner's English, rather than, let's say you have a bunch of transaction values with a dollar amount, rather than storing, let's say it's the customer balance, for instance. Let's say the customer has 10 open invoices and those open invoices total $15,000. Well, if you run reports on those balances, that may take a while. Let's say you have thousands of customers and each they have hundreds of open invoices. Calculating the sum of all of those could be time consuming. So some applications, such as Microsoft Dynamics GP, they sometimes store summary values to make that reporting process faster. So they will have a current customer balance field that says, okay, this customer has 10 open invoices that total $15,000. I'm going to store that. If the customer pays off one of those invoices, I'm going to decrease that value from 15,000 to 13,000. And it's constantly recalculating that amount based on activity that occurs on those open invoices. So a invoice is paid, it reduces that. A new invoice is added, it increases it. Well, the obvious downside is that there's the potential for something to change in your invoice list, whether it's a payment, a void, a new invoice, an adjustment, a discount, payment terms, you name it. Any changes to those open invoices that may, for whatever reason, fail to update the customer's open balance field, which is stored in a summary table. So when that happens, your summary amount is out of sync. Your invoice list will say the customer owes $16,000, but maybe the customer balance record says $15,000. Well, when that happens, you may have unreliable information. To address this, applications such as Dynamics GP have a reconcile routine, as it's called, to recalculate those values. It's a simple routine, runs quickly, but it's kind of one of those housekeeping routines you probably wish you didn't have to do. So what's kind of nice about this flow field approach is it tells the application, I want you to figure out how to do this. And behind the scenes, Nav or BC now will calculate those amounts on the fly. So instead of having a separate customer balances table, we can have a customer or a customers table, and on our main customers master table, maybe we have an additional column called account balance or customer balance. And when we pull up our list of customers, this flow field will automatically calculate open invoices for each customer. So it is an on-the-fly calculation. I don't know exactly, I think it's called, FlowFields or SIFT technology. Behind the scenes, I think it's using indexes and some other magic to make that process relatively fast, because that's the concern, right? If you have thousands of customers, thousands of open invoices, you want the ability to have that calculated on the fly, but you don't want to wait 5 minutes to get that benefit. So somehow, my understanding is Nav and BC do this fairly well, and it's pretty quick. So that's good to know. So that's what flow fields are. So let's just take a look at that page. Here is flow fields. You can define what the calculation is, whether that's a sum or average, etc. And it increases performance. It involves a series of accesses and calculations before a result is available. Using flow fields, the result is immediately available. You can further optimize by enabling or disabling SIFT. And that's what I mentioned before. So sum index field technology. So there's a page for that. So I haven't looked into how this is implemented, but my understanding is it works well, very cool, very reliable, and fast. So you can do a sum, average, exists, count, min, max, lookup. So it sounds like you can do some pretty clever things with a flow field. So exists. Maybe I want to know if a customer has any open invoices. Maybe I want to know if they have open invoices older than 30 days. So I can think of some really interesting things you might be able to do with flow fields other than just calculate, say, customer balance or the totals of a ledger entry or a GL account number, something like that. So they have a diagram showing how those are summed, and it's pretty obvious. It seems like, okay, structuring those calculations probably requires some knowledge. So customer entries dot amount where customer number equals this value. So I want customer entries for just this customer, and I want you to sum them. So that's pretty cool. In the Dynamics GP world, I'm pretty sure we don't have anything equivalent to this. We rely upon SQL objects, stored procedures, queries in order to perform that, and that can also be done at the application level to perform those calculations, although that's not particularly fast. So typically I think for faster calculations it's done in SQL, or it's done through one of those summary tables with pre-calculated static amounts. Okay, so that's flow fields. Very cool. Table keys. Database management system, which SQL Server uses a primary key composed of up to 16 fields in a record. Combination of values in fields in the primary key makes it possible to uniquely identify each record. So pretty standard business application database index primary key type thing. I wouldn't recommend doing 16 fields in a key. That's pretty scary for performance reasons. Oops. But that's your limitation. And if you're familiar with Michael Swart, he has a great blog post called Swart's Rule. And I believe, if I recall correctly, if you're using more than 10% of the capacity or the stated or documented limits of a particular feature, you might want to reconsider that. So rounding up, let's make that 2 fields. And in this case, since we're dealing with small numbers, 2 or 3 fields, you probably don't want to have 8 fields for your table keys on a regular basis. Now, I need to look in to see, maybe we'll see it on the docs page, whether this is, obviously it's defined in the AL code. I am curious if it's also implemented through a actual primary key object on a table. So let's take a look and see what that looks like. Table keys. They're stored sequentially. Okay, so it looks like it is implemented at the SQL Server level. SQL Server checks if the information in this record's primary key field is unique, and only then inserts the record in the logical position. Okay, records are sorted dynamically so the database is always structurally correct. So yeah, this sounds like a SQL Server primary key. Makes sense. Up to 40 keys can be associated to a table. Wow. Those sound like indexes. Secondary key, implemented SQL Server. Okay, there we go. Secondary key is, so that's interesting. A description contains a list of keys. A key is a sequence or one or more field IDs from the table. Up to 40 keys can be associated to a table. Oh, okay. The first key in the list is the primary key. So to me, that sounds like indexes. The first one is the primary key. Or primary key, primary index. And then secondary keys are implemented using indexes. This is like an index that is used in textbooks. That's the example I give in presentations. You go to the back of the book, look at the index, essentially the same as a SQL index for the metaphor. Okay, when you define a secondary key, mark it as enabled, index is automatically maintained on a SQL server. Got it. So these table keys in AL do seem to correspond to indexes on SQL Server. That's good to know. And it handles that through its entity framework or data access layer on behind the scenes in AL. Great. Fields that make up the secondary keys do not always contain unique data. SQL Server does not reject records with duplicate data. Got it. So I'm curious, do AL developers create table keys intentionally in order to provide covering indexes for their queries? I'm kind of curious about that. I don't know if that's difficult to do or if that's a common practice. That would be my way of kind of gaming SQL Server and tweaking it to produce results faster. So if I only need, say, the customer ID and customer name for a lookup or a query, I would want to have a key on that, table key, in order to get better results through a covering index. So, okay, sort orders, secondary keys, clustered, non-clustered. The primary key is configured as a cluster key, standard SQL Server stuff. Clustered property is not supported in table extension objects. Interesting, good to know. So the reason I mention that is because page extensions, table extensions, there are some performance implications. So if you say, oh, great, I'm just creating a simple table extension. Well, that's fine, but if 15 other extensions or ISV solutions are also implementing page and table extensions, you can run into some performance challenges potentially. How keys affect performance? Yep, decision of how many keys to use is not easy. Yeah, just like indexes. There's no like black and white answer. There's no simple, I can't tell you how many keys you should have on your table. When developing new versions of an extension, be aware of these restrictions. Do not delete primary keys. You need to design this in advance. Do not add or remove primary keys or change their order. Okay. Do not add keys that are field to the base table. Okay, so there's some background knowledge going on here when you design your table. So good to know. So pretty good documentation on table keys, primary keys. Okay, next up, table triggers. Need some coffee. So table triggers, Business Central recognizes certain actions that happen on a table when you use it. For example, when you insert and modify data. So if I'm inserting data into a table or a field, triggers, pretty cool. In response, you specify to execute AL awkward language, but basically you specify AL code to be executed in a trigger. They are predefined methods based on certain actions. Bodies of these methods are initially empty, must be defined by the developer. Got it. So I asked on Twitter using the very cool BCAL help tag. Let me just drag this over here. Okay, so I asked, are table fields and triggers implemented completely in AL at the application layer, or do they rely at all on SQL Server triggers or other database mechanisms? And Stefan very kindly, promptly responded, it is completely in the application layer. The database is not aware of any table relations. Awesome. Thank you for that, Stefan. Now, why is that important? Well, if you're doing something via the application layer, let's say you insert a record into some table, and there are AL table triggers on that object or even field triggers, you want those to fire. So let's say that when a record is inserted for a customer, it affects that some flag to say that they have open invoices or whatever, for instance. Now, that's great, but what if someone fiddles with the underlying database table? And in the GP world, we see that people are inserting and changing records at the database layer all the time. So the danger is that when that happens, application triggers are not firing. So maybe some other module needs to know when a new transaction is entered to calculate sales tax, for instance. If you're inserting in the database, that sales tax engine, it doesn't know that a new record was added. So it doesn't know that it needs to calculate taxes on that invoice. So just be aware, these are being calculated, these triggers are being fired in the AL application layer, not at the database. Now, in the SaaS world, which is my focus, is Business Central SaaS online only. I don't believe there's any way for us to get direct access to the database, so I shouldn't be fiddling with the records directly anyway. But if for some reason something weird happens, that might be why. Maybe something happened in the database layer and the application level trigger did not fire. I don't know if that's possible. Hopefully not, because everything should go through that data layer to fire. But I'd be curious to know if there's some way for, say, one extension to make a modification that could somehow slip by a table or field extension from another extension that owns that table. I'm assuming not. I'm assuming it's designed to handle that, but just be aware. Okay, get back to this. Okay, so Christoph in chapter 4 mentions a setup table. And this is a table to store configuration for our extension or custom module that we're creating. And we wanted to store the setup information and some configuration options. And so what I thought is, I thought interesting was he says setup tables have a unique structure compared to other data tables. They always store one record and they have one field as the primary key called primary key, and it is always blank. Very interesting that it's always blank. So that's kind of just kind of one of those things you need to know. And Dynamics GP actually has something similar. There are several setup tables like the purchasing setup table or the general ledger setup table. They usually have one record and they store things like the next transaction number or configuration options for that entire module. So very similar concept to have a setup table with only one record. And pages. So Chapter 4 goes on to talk about pages, and we have list, card, document, pages, page properties, page controls, actions, and triggers. Those are the ones that Christoph mentions in Chapter 4. However, there is much more to it, so I just wanted to mention those and show you the docs pages. So there are actually 13 different page types technically, and that would be, I'm assuming, the page type value that you set in AL. Now, you may rarely use some of these, but I think it's good to know about them. So let's look at page types. Oh, and here's the page for table and field triggers, just so you know, quite a few different triggers that you can have. So pages overview is the doc page, and here are the page types. So you can have a card, you can have a list page. There's a list plus, fancy. Worksheet, confirmation dialog, API. So I'm very interested in an API page. If you're interested in UI stuff, you probably would never use this, but I think that's awesome that there's an API page type now. So just be aware, there's more than just your UI page types. Okay, let's go back to this. Okay, so there are 13 page types. Be aware that of those docs pages. And he also lists some additional information for the upcoming development of our first few tables and pages. First is some table methods. So reset, init, insert, and get. And I'm assuming we'll learn about those. We have the if-else statement in AL. Then we have the onOpenPage trigger, where presumably we'll have some code, some action, some activity that occurs when the page first opens, such as maybe we'll load a record and populate some fields on the page. So that is actually a fair amount of information if you dig into it and review it. So feel free and check out those links on the docs pages. Review the table information, field types, field properties, triggers, page types, page events. Lots of stuff going on there. And this is just for part 1. So in the next video, part 2 of chapter 4, or episode 5 as it were, I will actually start into the code samples that he provides. We'll walk through that. We'll create a table and create a sample page and start the exercise of creating the bonus extension. And so with that, I'm going to wrap up and have a great day and enjoy your coding.